Okay, so in this video, we're going to introduce the idea of substitution as a strategy to solve a system of equations. Sometimes graphing is not going to be the best way, so we are going to try something called substitution with this story problem. So here we go. Jasmine was helping her mother make potato salad for the county fair and was asked to go to the market to buy fresh potatoes and onions. The onions cost $1.25 per pound, and potatoes cost $1.05 per pound. Her mother told her to use the $30 she gave her to buy these two items. Okay, so we're going to start with writing an equation in standard form that relates the number of pounds of potatoes and the number of pounds of onions that Jasmine can buy for $30. We will use X to represent the number of pounds of onions and Y to represent the number of pounds of potatoes that Jasmine can buy. So I'm going to code my text right now with that. So X is my number of pounds of onions, and so the onions were $1.25 per pound. And then my pounds of potatoes is Y, and the potatoes were $1.05 per pound. And then we have another amount, $30. Okay, so in case you forgot, the standard form is going to be AX plus BY equals C. And so X represents the pounds of onions. So we have $1.25 X. So $1.25 times the number of pounds of onions plus $1.05 times the number of pounds of potatoes. When I add those two amounts up, it's going to equal $30 because that's how much he has to spend. So this is our standard form for that line. So we'll go to the next one. Jasmine's mother told her that the number of pounds of potatoes should be 8 times greater than the number of pounds of onions in the salad. Write an equation in X and Y that represents the situation. So we have our onions, and then we have our potatoes. So the potatoes are greater, 8 times greater. So the amount of potatoes, which is X, is 8 times the amount of the onions. I have this backwards. The pounds of potatoes is Y, is 8 times greater than the number of pounds of onions. So my second equation is Y equals 8X. Okay? And so we normally at this point we could graph this. But I don't want to graph this because these decimals are going to make things tough for me to calculate my slope. So we are going to use the idea of the substitution method. So the steps for substitution method are right here. Step 1, select one equation and isolate a variable. Step 2, substitute the expression equal to that variable into the other equation. Step 3, solve this new equation. And then step 4, substitute the value of your variable into one of the equations to solve for the other variable. So these are my two equations, and instead of graphing them, we're going to use the substitution strategy. So step 1, select one equation and isolate one variable. So I have 1.25x plus 1.05y equals 30, and my other equation is y equals 8x. So I'm going to select this equation because y is already isolated. It doesn't have to be y, it could be x, but because y is already isolated, I'm going to use that. So I'm done with step 1. Step 2, I need to substitute the expression that's equal to this variable into the other equation. So this 8x is going to be going into here because that is y. Okay, then I'm step 3. Solve this new equation. So I have 1.25x plus 1.05, and instead of y, I'm going to use 8x because 8x is y. So 8x equals 30. Then I have 1.25x plus 8.4x equals 30. And then I'm going to combine like terms, and I'm going to get 9.65x equals 30. And I'm going to divide both sides by 9.65. And I'm left with x is equal to 3.1. So now I'm at step 4. I need to substitute the value of this variable for x back into one of my other equations, either this one or this one, so that we can find y. I'm going to substitute this variable for x back into this equation here, so I can find y. So y equals 8, and instead of x, I'm going to put what I found x to be, 3.1. So then after I distribute, y equals 24.8. And now I have a solution to my system. So my solution to a system is going to be a coordinate pair, just like when we graph it. So my x value is 3.1, and my y value is 24.8. So that is my solution. But in terms of this problem, this 3.1 represents the pounds of, what was it? Onions. Pounds of onions. And my y value was the pounds of potatoes. All right, and if I were to graph it, this would be the coordinate where both of these equations, where their lines would intersect. All right, that's this video.